Good morning and welcome everybody. Thank you for joining us this morning for the Steel Bridges for Local Communities webinar. This webinar is brought to you by the Short Span Steel Bridge Alliance and is hosted by the Minnesota Local Technical Assistance Program, or LTAP. My name is Natalie Niskanen and I'm a program coordinator with the Minnesota LTAP. I'm just going to provide a quick overview of the LTAP program before introducing today's presenters from the SSSBA. So the Minnesota LTAP is housed in the Center for Transportation Studies at the University of Minnesota. It's one of 58 centers nationwide, and our program is designed to provide local transportation agencies with the tools to improve operations through training, events, demonstrations, technical assistance, and technology transfer. And while we focus efforts on supporting local agencies, everyone is welcome to utilize our resources, whether you work for a consultant or contractor or work for a local agency in a different state or even a different country. Minnesota LTAP provides multiple training opportunities throughout the year at convenient locations around the state, and we also invite locals from neighboring states to participate if it's convenient and relevant to them. And we also offer self-paced and instructor-led online courses, and everyone is welcome to check out our online training calendar to see what's new and upcoming. Just a quick overview of our website, mnltap.umn.edu. You can find a menu of all of our training offerings in our calendar. A quick plug for our job openings page. We're hiring instructors for in-person and online courses and workshops. And then finally, at the top, you can subscribe to our newsletters to get the latest on upcoming training offerings. And then a few housekeeping items. We will be sending out a post-webinar survey. It'll pop up afterward, and I'll also send it to your email inbox if you don't have time to do it right away. That's your opportunity to tell us what you need so the Minnesota LTAP can best serve you, and also just provide us feedback on today's webinar. And then we are also going to be sending out a PDH form to everybody who attended the webinar afterward. And then final housekeeping item before we turn it over to the SSSBA, we will be utilizing the chat function that is the bottom bar there. Put your questions as we go along, and we'll be responding to those. And at the very end, we will have folks raise their hands if you would like, and you can unmute to ask your questions. And then I'll turn it over now to today's presenters from the SSSBA.
Okay. Thank you, Natalie. Am I up and everybody see that?
Yes.
Okay, good. Thank you for hosting us, Natalie. We really appreciate it. I am Michael Barker. I am a professor of civil and architectural engineering at the University of Wyoming. I'm also the director of education for the SSSBA, the Short Span Steel Bridge Alliance. With me today is Dan Snyder. He's the director of the Alliance. He is going to be monitoring the chat. And so if you have a question or a comment, please use the chat. Make sure it goes to everyone. And feel free to comment on other people's questions or other people's comments. And if Dan can answer those questions, he certainly will. If not, he will save them towards the end. So, of course, this is the Minnesota Local Technical Assistance Program January 15th webinar from the Short Span Steel Bridge Alliance. So who are the Short Span Steel Bridge Alliance? We're a group of bridge and buried soil structure industry leaders who have joined together to provide educational information on the design and construction of short span steel bridges. Our chairman is David Stoddard, one of our steel manufacturers, SSAB. Why we are. We started in 2007 with a couple major objectives. One was to remove design obstacles for short span steel bridges, and we're going to talk about those today. Overcome the preconception that concrete is always less expensive in the short span. We're going to talk about that today. Prefabricated steel bridge systems and accelerated bridge construction. We're going to look at some case studies. And then our innovative steel bridge systems that have been developed through the SSSBA or other mechanisms, and we will talk about that today. And of course, today is an example of it, but we are out there to educate owners and engineers and students in steel bridge design. So as the director of education, I kind of categorize my education programming as the 5 C's: cost, convenience, construction, county built, and carbon. Now, the ones that are circled here in red, we're going to talk about with some examples and that kind of thing. And coming soon is resiliency, but I don't have that in the 5 Cs because I can't figure out yet how to do an R with 5 Cs, but that's coming soon. So what we're going to talk about today is initial costs of steel and concrete bridges, or dealing with that preconception, life cycle costs, because responsible owners should be considered, should consider life cycle costs and long-term performance, that a design tool, eSpan 140, which will give you a steel bridge design in a matter of just a couple minutes. And then, of course, Bridge Manufacturer Solutions, where our Alliance members will build you a bridge, design a bridge, sign a bridge, and deliver it to you. Then we've done quite a bit of work with local crews building county bridges. And so we're going to talk about that a little bit. And then an innovative system, simple for dead, continuous for live, steel bridge construction, which is an innovative design thing. Then we're going to end up talking about how you can find out more information, or what our resources are, or additional training. And we only have time to quickly address all these topics today. And so Natalie is going to send out that survey to let us know what you're more interested in and how we can get you some more information. But all of the information, and a good place to visit, is always shortspansteelbridges.org, our website. So let's start. Initial cost, steel versus concrete. So when we started this back in the late 2000s, there was across the country a preconception that concrete is less expensive than steel bridges for typical bridges, simple span bridges. To the point where in many states or many counties, many times steel was not even considered. They just went directly to a concrete bridge. And what we found, and what the National Steel Bridge Alliance found, is that the owners are paying more for those concrete bridges when there's no competition than if there is competition. And that unwarranted lack of competition is not good for anybody, the public or the owner. And so the Alliance has done, I can't tell you how many studies on first costs, and I'm not going to go through them individually just because of time, but I will show you where we're going to be giving this presentation here in February, a little bit later in today's talk. But we've conducted case studies where we look at county bridges and state bridges, and we look at actual costs and bids and that type of thing. And so this is just a kind of a smattering picture of some of the case studies we've done to show that, yes, that preconception that concrete is always less expensive than steel bridges is a misconception, that steel and concrete bridges are competitive. So I'm not sitting here saying steel is going to beat concrete. What I'm saying is, hey, we should consider both steel and concrete so that we get the best product for the best price. And you can visit these studies or look at all these studies on that website, shortspansteelbridges.org. But what about life cycle costs? Like I said earlier, responsible owners are starting to look at life cycle costs and life cycle performance of bridges. And as owners replace those bridges, the question of life cycle or life service and life cycle costs comes up. It's one of the most common questions I get when I go out and talk to counties and states. And the bridge industry, it says, does not have a good answer. And I crossed that out and said, did not have a good answer. In fact, the concrete people always said, oh, no, concrete bridges have better life cycle costs. And the steel bridge people always said, the steel bridges all have better life cycle costs. And they would give their information, and that anecdotal information was not very convincing. And so the Alliance did a study, back in 2015, I believe, where we looked at the historical life service, or the performance and maintenance, and agency life costs, or life cycle costs, or the true agency costs for a bridge of steel and concrete bridges in Pennsylvania. And we looked at a very large database, like 1,700 bridges. And it looked at the historical life service because that's what actually happened. And the study, the initial year for the study was 1960, when precast concrete became very popular and quality steel detailing became popular. So it looked at more or less modern bridges. And the conclusions from all this. Now, this is a big study, and again, I'll show you where we're going to be giving this here in February. that typical concrete and steel bridges, we're talking about, you know, the boxes and the eye girders and the rolled beams and the plate girder type bridges, are competitive on initial costs, which we already knew, future costs and life cycle costs, and even bridge life. And the conclusion of this study is that owners should consider both steel and concrete bridge alternatives for individual bridge projects. That when we looked at all of that data, that all the types of bridges are similar with none way out of balance, meaning none have high life cycle costs compared to the others or low. And you can find this report on the shortspansteelbridges.org website. And then we also did a study on galvanizing. You know, galvanizing is a long-term steel protection system. And so the industry was interested in what kind of effects does galvanizing have on life cycle costs. You can find that report there also. Okay, so we've taken care of costs. So the Alliance kind of deals with these type of bridges, where yes, corrugated steel pipe, or what we call culverts, is a buried steel bridge, and that's certainly one that our group associates with. And then you've got corrugated steel plate, which is kind of an arch bridge, right, with corrugated arches going across there to create the bridge. And then, of course, the rolled beam shaped bridges and the plate girder bridges. And then our manufacturers certainly have their truss bridges. And then as part of the Alliance and industry, we developed the press brake tub girder. And we're going to look at an example of that because that's one you might not have heard of before. But if we think about the bread and butter bridges, the traditional fabricated steel bridge where a county or a state wants to put in this 80-foot bridge. Well, in the beginning, that owner or the engineer has to make some decisions on the service performance of that bridge. Well, of course, for the hydraulic opening and all that kind of stuff, we need this 80-foot simple span composite bridge where we're going to build it out of steel girders. We're going to have two 12-foot travel lanes with an average daily traffic, a certain width, and we're going to use Jersey barriers because we want to protect the water underneath maybe. Okay, that's the service part of the bridge. That's what you see when you're driving over it. Now, we need an initial design for the bridge superstructure. What kind of girders are we going to put underneath that meets all of the AASHTO requirements and is economical and performs well? Well, the Alliance developed this eSpan 140, which is a free design tool that you can find on shortspansteelbridges.org, where it has just created a very large database of different designs that meet all the AASHTO criteria for span lengths, you know, from 20 to 140 foot, for different girder spacings. And for each one of those, eSpan will give you the steel girder design, the shear stud design, stiffener layouts, welding, fabrication details, even the bearings and the concrete deck design. And so if we need to design this 80-foot span bridge, we go into eSpan, it's actually going to give us kind of 4 or 5 solutions. Yes, it's going to give us a rolled beam solution and a plate girder solution, but also one of our manufacturers or some of our manufacturers' solution like the press brake tub girder or buried bridges that we'll look at a little bit later. But for an 80-foot span, it's going to give us a rolled beam and a plate girder. It's really simple to run. You put in how long the bridge is and how many lanes you have and what your roadway width is and what your barriers are. And it's going to give you some designs that meet all the AASHTO requirements. This is an example of the lightest weight rolled shape design. It also does limited depth rolled shapes. And it says, hey, let's put those girders at 10 foot 6 inches and let's make those W36 by 210s and let's have some diaphragms every 20 feet. Boom, just in a matter of minutes, you know what it's going to take. For the plate girder, hey, with plate girders, we can optimize a little bit better. We can get rid of some of the weight by transitioning the flanges and making the web thinner. Here's a plate girder, a homogeneous plate girder made out of 50 KSI where it says, yeah, we're going to have a top plate and a bottom plate. We're going to transition that bottom plate. We're going to have a web, and we're going to have those diaphragm spacings at 20 feet. And now, in just a matter of minutes, we have a design that we can put on the table and compare to those concrete options and then let the market decide. Now we have a superstructure designed for that 2-lane, 80-foot simple span bridge in just a matter of a couple minutes. Now, I did say that eSpan will also talk about manufacturer solutions. We have prefabricated bridge manufacturers that are part of the alliance that do truss bridges and modular bridges and ABC abutments and all the whole range of things, whether they're buried or rolled or plate or truss. We're going to look at three of those, three different types of bridges. So these are prefabricated, which kind of means they can be accelerated bridge construction bridges. And we're just going to look at a showcase of three different types of steel bridges. And the first one we're going to look at is a buried steel bridge, one of those arch bridges from Big R. A modular beam bridge, the most common type of prefabricated bridge from Contec. And then one of those press brake tub girder bridges that you might not have seen before from Valmont. And these prefabricated bridges, these bridge manufacturing firms and traditional fabricators fabricate and deliver many styles of steel bridges. And these case studies are just a sample of the varieties that they produce. And of course, you can get more information just from an internet search, but also from our website, shortspansteelbridges.org. So for this first case study, this corrugated steel plate buried steel bridge was built in St. Johnsbury, Vermont. The bridge was fabricated and designed by Big R Bridge in Greeley, Colorado, and built by J.P. Sicard. The bridge is located on a steep, narrow site on a curve with residents living right nearby. And there's poor soils on the site, so the designer needed a system that could accommodate significant differential settlement. Now, limiting the days of the trail could be closed, so this is a rails to trails type project, and constructing the bridge before the peak summer and fall seasons was a priority of the owner, and the contractor had a maximum 50-day closure of the roadway. But they actually earned a monetary incentive when it was reopened after only 45 days. And so this ABC project used precast concrete foundation blocks and precast wall panels to significantly shorten the construction time with no concrete curing times. And so the corrugated structural plate is stacked and shipped to the site and bolted together to make the arches. And then light equipment can be used to lift the arches and connect them together across a width for stabilization. And then the bridge arch is covered with soil and the roadway built. A buried steel bridge is lighter weight, flexible, and able to handle anticipated settlement. With the lightweight structure, the Vermont bridge was able to use those precast footings. Because of the arch, shorter spans are required to achieve vertical clearance requirements, and there is a continuous road surface with no bridge deck or joints to maintain. So that was our first example, a buried steel arch bridge. They also come in lots of different forms. For instance, that was kind of a significantly large bridge. Here's a small bridge for over a small opening in Alaska, where the tribe workforce built this bridge with their local equipment. Now, the environmental people really like these types of bridges because in comparison to a culvert, they have a natural stream bed underneath for fish passage and environmental concerns. And so here's just an example, another one, a smaller one, where these buried steel bridges can be used and even built by local workforces. So the prefabricated modular beam is probably the most common prefabricated bridge out there. This one is a county crew built bridge. It was built in Whitman County, Washington, and it was a replacement project built by county forces for an originally built 1952 wood structure. The replacement bridge was planned to have a longer span in order to improve the hydraulic opening under the bridge, which is very common. And this also made it easier to build the new foundations behind the existing wood foundations. And one of the goals of the replacement bridge, of course, was to open the channel wider and raise the bottom chord of the bridge above the 100-year recurrence flood. And then this is again a gravel surface bridge. Now the successful bidder with the lowest cost was a modular rolled beam steel structure supplied by Contec. So the final dimensions for the new superstructure were 35-foot long and 28-foot wide. The modular rolled beam steel bridge consisted of 3 modules that was shipped out to the site on 1 truck. And each module had 2 weathering steel rolled beam girders fully assembled with a corrugated steel deck for the gravel riding surface. Now, these are just a few of the pictures of the 2 girder superstructure modules being erected. The modules are shipped to the site, assembled with corrugated steel decks, side dams, simple cross-frame diaphragms, and guardrail stubs. Front end loader and excavators pick up the modules and place them on the abutments with the bearing assemblies. The modules are connected together using simple connection details. The guardrail stubs, guardrails, and back wall are installed, and the gravel roadway surface installed. And so here's where selecting a bridge structure that can easily be handled by 1 or 2 excavators significantly reduces the overall project costs and shortens the construction time. Modular steel bridges in particular fit this product category as they are relatively lightweight, are easy to handle, and match fit well due to the quality of shop fabrication. And with no concrete curing time, the bridge is ready for traffic. Now, this Celtus Warner Bridge project was started on June 15th and completed and opened to traffic on July 15th in 2020. Whitman County sought competitive quotes for the manufacture and delivery of both steel and concrete superstructures for this site. The cost for the concrete alternative was $82,000 and the cost for the modular beam was $56,000. And so I just put this in here to show that one example where, yes, steel is competitive and steel should be considered. And then, of course, with the cost and labor and equipment, the pile foundation and permitting, the total bridge cost was $159,000 or $162 per square foot. County crew built bridge. Now you have a company right there in Minneapolis, Minnesota. Now we thank everybody for joining us. And this was we started with Minnesota LTAP, but because of the word of mouth and the marketing, wow, we have people from all across the country. But I do want to mention that in Minnesota, you have one of these prefabricated bridge manufacturers right there in Minneapolis and Wheeler. And here's just a couple examples of bridges that they have produced in the past out in Utah, where they had to replace a bridge that serviced a lot of agricultural area out there, and they came in with a modular beam bridge with a concrete deck. And then on the one on the right in Wisconsin, there was a storm that took out a bridge. And we're talking about in the winter months. And they needed that bridge because it cut off part of a community. And Wheeler was able to come in there with a no concrete steel and wood bridge and replace it during the winter months with accelerated bridge construction. And of course, you can contact Wheeler or any of these other manufacturers through the website or through your own internet searches. So we've got one more we want to talk about here. This is a press brake form steel tub girder. So FHWA came to the Alliance back in about 2012 and said, hey, what is the next modular accelerated construction steel bridge product that we should be pursuing? And we got a lot of people together in Chicago and went to a Cubs game and also met and came up with a press brake formed steel tub girder where you take a standard width plate, put it in a brake and bend it into a tub, put some shear studs on it, put some concrete on it. So you have these modules, and then you go out and you just put them in place. So that reduced in fabrication costs, because yes, tub girders have been around a long time, but you take a flange and a web and you weld them together. There's no welding here, which removes fatigue issues, which reduces costs, and they can be mass produced. And it reduces stiffeners and cross frames. And these can be accelerated bridges. In fact, you can, with a precast deck, you can install these bridges in 1 or 2 days. They are modular, they're simple to fabricate and install. Now, our research on that started in about 2012, but there's a guy in Michigan that actually put one of these in place in 2004. Now, that same guy who built that 2004, he went to a company called Valmont and said, hey, how about we develop a division here to produce these press brake tub girders? They call them U-beams, but it's still a press brake tub girder. And this is not a proprietary design, but Valmont decided to take this and run with it. And they've done a a really good job, as I'll show you on the next slide. And so the bridge I'm going to show you is here from Barron County, Wisconsin, where there was an existing timber slab structure, 96 foot long. It was old and they needed a new structure. And Barron County went with a two-span, 104-foot length. So that, of course, they increased the hydraulic opening a little bit and clearance a little bit. And they used these press brake tub girder bridges. And so at Valmont, they developed this whole system where they bring in these standard width plates. They came up with efficient ways of bending them. Then they have a machine they developed for cambering them. Again, another machine to put on those studs. And then, of course, Valmont likes galvanizing, which is really a good steel protection system. And they have all that stuff right there because they're poles. They build these tubs. For this bridge, they built the tubs without a concrete deck, shipped them out there, put them in place, put on the concrete or shorted up, put in the rebar cages, cast the deck, put on their guardrail, and they have this two-span bridge. Now, you also can precast these things. One is precast the decks right on those tubs, and Valmont will do this for you, or you can do it on your own with your own fabricated, where now you send out pre-deck modules and you put in a longitudinal closure pour with like a UHPC or something like that. Or the bottom slide here shows where, yeah, those tubs go out as individual tubs and they have the studs on them, and you put precast deck panels on them with grout holes and all that kind of stuff. And you do the closure pours in the grouted shear pockets. And so if you have questions about these, you can contact the Alliance or you can go to Valmont directly. Okay, so we looked at a couple bridges that were contractor built, and we looked at one bridge that was county built. And so the Alliance started putting together some educational resources for counties for them to consider whether they should be building their own bridges. Because there are a lot of bridges in the counties that need replacement. And we need cost-effective and sustainable solutions. And one option is to use county crews for bridge installations. For instance, this slide here says Mark Story up in Whitman County saved over $30,000 by using local crews to install a prefabricated steel bridge. It also develops his workforce. So the Alliance developed a DIY county bridges education packet where there are over 3,000 county type organizations in this country. And the purpose of the packet is to have counties consider whether they should be building their own bridges, because counties can save money and of course build more bridges, which is very, very important for those counties. It can use accelerated construction and minimize public inconvenience because they are in control of the work site, and it develops county workforce and uses county equipment. So we came up with 6 topics. There's kind of 6 lectures in this, where starts off with, can your county build this bridge, and then moves into planning, permits, environmental issues, geotech considerations, and then how to select a bridge type and bid for that and award that. And then foundations and substructure design and installation, because there are some easy ways that the county can do it, or you can subcontract that out and have a contractor build you one. And then, of course, installing the bridge. That's actually the easy part, especially if you buy one of these prefabricated bridges, and then commissioning and opening to traffic. And so we use this Belmont Bridge in Whitman County as a learn by example for how a county can build their own bridge. And it starts off with the existing bridge being a pretty old, deteriorated wood bridge, only 20-foot long, and the new bridge being 30-foot long. So we increase that hydraulic opening, increase the clearance, 20-foot wide. And this is a true north modular steel bridge, and then installed by the county crew. Now at the bottom there, and I know that Natalie and Dan Snyder are going to post these on the websites later. Take a look at that video. It's pretty cool. That's just a video that talks to the bridge engineer and the bridge foreman and the workers on how they came up, or how they developed the capacity to be able to do their own bridges. So that's a good video. I'm not going to show it here, but you are certainly welcome to go through with that. And True North is one of our Alliance members. Now, we gave this talk to NACE, the National Association of County Engineers, in 2022 with just a 1-hour presentation. They weren't sure what they were getting. And I, Michael Barker, and Mark Story, that engineer from Whitman, went and just gave a 1-hour talk on this. And it was very well received. They were really happy with it. And so they invited us back for a 2-hour session the next year for NACE. So we know there's lots of bridges that need replaced. We know there's ways to do that. We know we have alternatives for materials and construction and all that kind of stuff. And one of the driving factors for getting this done is the new bridge infrastructure law, right? And in that, you can get good federal money for doing bridge projects on a local level or a state level with a state-local partnership. Now, the minimum amounts are pretty big. And so even in the BIL, they talk about bridge bundling. Hey, let's get several bridge projects together that are coordinated in the design and construction to help economize, save money, and get these bridges built. And a lot of this money under the BIL and of course the BIP, the Bridge Investment Program, are targeted for tribes or local bridges or off-system bridges. And so there's money to go after, and bridge bundling becomes an important part of that. Now, Missouri DOT is probably one of the leaders, if not the leader in the country, for design build bridge bundling. They've had lots of contracts, they've done lots of projects. And one of those projects down here at the bottom, a little bit left, circled in red, is called the Farm Project. And I'm just going to talk about that a little bit because I think it's important to see how this state does their bridge bundling design build projects. So FARM stands for Fixing Access to Rural Missouri. And what happened was MoDOT identified up to 40 bridges in northern Missouri for replacement. But they do it a little different, or maybe I should just say that they're a little unique in the way they do it. They don't say, hey, how much will it cost us to do these bridges? They say, we have acquired this much money, or we're willing to put this much money. Tell us what you're going to do with that money. And then they're looking for the best value for that fixed budget. And then they have a scoring system where it's not just the maximum number of structures or the maximum square footage or that type of thing. It looks at, yes, the number of structures and the size of those structures and the ADT and that kind of thing. But that's only part of it. That's 55 of 100 points. Then they look at bridge quality and longevity. So they're bringing in those other aspects, not just maximum square footage. And that's worth 30 points. And then completion and maintenance of traffic or kind of accelerated bridge construction and control of the construction site and that kind of stuff. And they rate those. And so, of course, the number of bridges and that kind of stuff, where there's a base and a bonus part of that, is 55 points. And then the bridge quality and longevity, they scored by a team of 8 technical experts. And then for the construction part, the completion and maintenance of traffic was scored by a team of 6 technical experts. And again, they're looking for a best value for a fixed budget. So 3 teams had qualified proposals, team 1, team 2, team 3. The first 2 were primarily concrete. The third one was primarily steel. And what we see here is that the primarily steel bridges won the bid. And of course, that's why that's part of my talk today, because if it was the concrete bridges that won, we wouldn't be talking about this today. But the steel bridges won, and we want to look at why. So how did the steel win the bid? Now, there's lots of reasons, but there's really an important one here. There's 25 multi-span bridges in the winning package, and the bridge bundling was 40 points, or for the bridge bundling, the steel bridge proposer won with 40 points plus 1.5 bonus for the highest score. There were 31 bridges replaced, but they used an innovative simple for dead, continuous for live load designs. And when we talk to the owner, the contractor, the designer, and the fabricator, they believe because they use this innovative system is the reason they won this contract. For quality and longevity, they also had the highest score because they have galvanized beams, and that impressed MoDOT because of the 100-year expectation at least in these rural settings. And they used a full depth cast in place deck versus the partial deck thickness decks. For completion and maintenance, because of ease and pace of construction and the weight of bridge and lighter equipment uses, they had the second highest score. So let's just look at the Simple for Dead Continuous for Live, or SDCL. So multi-span bridges using simple span and wide flange beams with simple details are laid out there on their supports, and then when the deck is cast, it is made continuous. And so you cast or you form up the pier region to make that continuous connection of the simple span steel beams. And you have a compression block at the bottom, and you use the deck for the tension side. Then you, just like any other bridge, you put on your rebar cages and you cast your concrete, and you put on your guardrails or your rails, and you got yourself a bridge. So what are the advantages for the Simple for Dead Continuous for Live? Well, certainly ease of construction. Slinging around a bunch of simple span steel girder bridges is a lot easier than long continuous spans, because those are going to have field splices that you have to put together, and field splices can be expensive. And then because there's a set of simple span bridges, you can have flexible and economical span ratios, and you can customize the beams to the spans. But here's another big one. Because of the simple details in the fabrication shop, it makes it more competitive, because the fabrication shop only needs to be simple bridge certified instead of intermediate or advanced bridge. If it had splices and other more complicated details, they would have to be certified at a higher level than for these simple bridges. And then you look at some other benefits of this, the beam weights. The steel beams, a typical steel beam was an 18 by 158. That's only 9,500 pounds, where the concrete precast beam type 3 is 24,000 pounds. Much less weight, lighter equipment needed. And then, of course, depth is always important because of abutment work and, approach work. And so you have shallower depth. Again, here we have an 18-inch depth, or almost 20 with the W18, whereas a concrete bridge is almost 40. So that was those three different types of bridges we looked at, and then how we can look at bundling bridges and going for some of these federal funds. And so in summary, today's steel bridges, yeah, they are state of the art, and they have innovative designs, as we've seen today. They are durable. There are thousands of bridges that are over 100 years old. Speed of construction, they're light, small equipment. We can use accelerated bridge construction, especially those prefabricated bridges, because they've already worked out all the design details and fit details. They make hundreds of these bridges, so it's going to go together well. Cost effectiveness, they are competitive. Sustainability, we've done some sustainability studies where we show that steel is very competitive with concrete, and resiliency. And so we're coming towards the end, but not quite at the end. Here are 5 ways to keep learning about steel bridges. We have a weekly newsletter that goes out every Friday morning that has interesting things or interesting upcoming events from the Alliance. You can find one of these suppliers, whether it's a traditional fabricator or a traditional design firm or prefabricated bridge manufacturer there. You can use that eSpan 150 or 150, eSpan 140 to design a bridge, and take one of your old bridges or take a new bridge coming up and just see what it gives you. See if it can help you. And I do want to say that eSpan is being upgraded. Right now it does composite bridges. It's going to do non-composite and composite bridges sometime in 2025. We're working out the final details of that. There is a Bridge Technology Center where you can receive free project assistance. And then the one I've got circled here, schedule a workshop or a webinar. Now, of course, today is a webinar. But let's talk about some of the webinars and things we do. For years, we've been doing the online university lecture that we call Part 1, which is Steel Bridges from Concept to Delivery. It's to get students and faculty and young engineers familiar with steel bridges and the steel bridge industry. On the bottom left, you can see the topics, or you can go to the website, of course, to see the topics, where this is not a design workshop or online education packet. This is the industry one where we're talking about all different aspects of bridge design. Now, we've had 10 workshops. We did not do one in 2024, but we are doing one starting next month in February. It's 2 times a week. It's going to be 1 p.m. Eastern, I believe, and you can find out more information about that. And we have great reviews. We give a certificate for it, suitable for framing, as Dan Snyder likes to say. But there's a certificate from the Short Span Steel Bridge Alliance and the University of Wyoming for 6 professional development hours. Now we have a new one coming up this year. First offering is going to be in fall. This is a design education packet where we're going to go through the design of an 80-foot simple span plate girder bridge. And again, you can see the topics. Again, it's 6 lectures. We're probably going to do 2 a week or maybe only 1 a week. We don't know quite yet. But we're going to get into how to get a trial design, what it takes to design that bridge, and then how to detail that bridge. And again, it's going to be based on National Steel Bridge Alliance's recently released routine steel bridge design, or navigating routine steel bridge design. Because if you know the Astro specifications, they are quite complicated, and for a simple span bridge, it should be simple. And our target audience for this are university students and young professionals. So you can look for that in the fall. We do workshops. We've done workshops all over the country for counties, for state DOTs. I put a few of the recent ones down there on the bottom left, where if you're interested in your state or your county state association, or even if you're a large design firm, of having the Alliance come in and do a workshop that's tailored to what you need. You know, we do show some standard 4-hour or 6-hour workshops. And part of that survey that Natalie's going to have you fill out at the end may lead to one of these workshops in some part of the country that you can attend. And then we're starting something new this year. We are coordinating with the American Galvanizers Association for a quarterly Building Better Bridges webinar series. This is brand new. We just settled on everything about a week ago, and the first one is February 19th. It's already, the registration for that one's already open, and that one's going to be on steel versus concrete life cycle performance and costs. And that's where we're going to get into that very short 3 slides I showed you earlier, and show you what we really did and why it's validated, and why we really do need to consider both steel and concrete. And then in April, September, and December, that's kind of the quarterly idea. We're going to be looking at some other things. For instance, in April, those buried steel structures. In September, we're going to look at that E-span 140 and some newer design tools to where you can design a steel bridge in just a matter of a minute or 2. And then in December 10th, we're gonna do a more full presentation on Simple for Dead Continuous for Live designs for optimal performance. And these are free. You sign up, you get PDHs. Go to the websites, either AGA website or ours, and you can find those. And then, of course, that DIY county bridges in 6 steps. If you've got a county where you want to consider, hey, should we build up our workforce, use our own equipment, maybe buy one of these prefab bridges, maybe piece together one from a traditional fabricator. Let's build our own bridges. If you're interested in that, you should contact us, because we've got lots of county engineers that are part of the Alliance that do their own bridges, and they would love to come talk to you and talk about how you can build your own bridges. And instead of building 4 bridges a year, or maybe even only 2 bridges a year, you can double it, or at least increase it by 1/3. And with that, I'm going to end here. Dan Snyder is our director. He is on the line. He's monitoring the chat. We will get with him in just a few minutes. But I really encourage you to visit shortspansteelbridges.org. There is just so much there. And if you're interested in scheduling a workshop or a webinar, contact us. It does not cost you anything for the workshop. We coordinate with here, an LTAP or maybe an ACEC or maybe a DOT, and they take care of the arrangements for the room and the invites and the registration. And then it doesn't cost anything to have us come and talk. And so we encourage you to contact us about that. And here are the 5 ways you can keep up. And with that, I am done. Thank you for attending. If you have any questions, contact us. Stay safe.
Thank you so much, Michael. I know we had some hands raised earlier. This is the time to raise your hands and we can unmute you to ask your questions. So want to go ahead and hit at the bottom of your screen. Just let us know and I can unmute you here and Dan and Michael can answer questions. Let's see. Otherwise, thank you everybody for joining.
Dr. Barker, let's see, there's a couple in chat you might want to respond to that I didn't get a chance to yet. One from Brandon, are there manufacturers that make prefabricated steel bridges with steel decks that have crash tested railings? I've only found crash tested railings with a concrete deck.
Boy, I can't answer that with 100%, but yes, our bridge manufacturers can have a TL rating on their railings. I never considered that they couldn't, but I can't answer that 100% positive, but I don't see why they wouldn't have a rated railing.
And we have some manufacturers that are on the line, so if you want to answer that in chat, go for it. One other one, and I did respond, but maybe you have additional information. Dr. Barker, how can load camber be maintained for roll beam bridges?
How can camber be maintained? Okay,
right.
so camber is developed in the fabrication shop, either cold bending or heat treating, right? And then it's going. So what a camber does is really gives us a hump. So we put the bridge out and we put the hump up. And then when we put the dead load decking on there, we want that hump to come down some so that it's a smooth surface. So the camber is put into place in the shop, knowing that we want some of it to come out when we put the dead loads on the bridge. And they do it either by cold bending or heat bending.
And I just saw a response from Matt with Wheeler regarding the tested railing, and yes, they do them for TL2 and TL4 railing options. And there's a few other comments there also.
Okay, yep, there are some comments there. Good.
And Natalie, I'll turn it back to you. Any other hands raised?
We've got a question in the Q&A here. I don't know if you can see that, Dan.
Is galvanized steel deck better than latex modified concrete deck? I don't know the answer to that. Better how? For corrosion, for deflection, for performance? Because a galvanized steel deck, okay, you can have stay-in-place forms for forming a concrete deck, or you can have a corrugated metal deck that is for a gravel type deck or an asphalt type deck, and they perform well. And I don't know much about latex modified concrete deck. Are we talking about stay in place? You know, those 3-inch stay in place ones? I'm sorry, I don't quite understand the question. If anybody else wants to respond to that. So yeah,
okay, we'll look in chat if anyone has any more answers.
Yeah, we might not.
One question from Benjamin. Any thought on using stainless steel or press brake tub girders? That'd be maybe Valmont can answer that question. I'm not quite sure what their
So
future plans
stainless,
are.
there is a stainless grade steel out there where there has been a bridge design of a girder type bridge designed out of it. And I believe that Contech is looking at using some stainless in their buried steel. Oh, I just saw. Oh, okay. So it's cost prohibitive. It is expensive. It is expensive. So you would need to find that niche area that justifies using stainless, because it is the premium on stainless is quite high. But that niche area is out there, right? You have these highly corrosive environments where stainless might be the most economical system. Whereas typically, you know, here in Wyoming, we don't get a lot of rain. We don't use a lot of salts. We like weathering steel. Other places use a lot of salts. They like galvanizing. There are places where, you know, they're in a marine environment and they use a lot, they have more corrosive environments. They might like painting. So what we really want to do is match the correct steel protection system to the environment. And we're actually going to give a 2-hour workshop on this at the NACE meeting coming up here in April. And I'm sure after that, we will probably have some educational materials on the website on steel protection systems that will help. But yeah, stainless is an option, but you have to find the right fit.
Okay, we have a question on Eastband 140, and I think it was how long it takes to update Eastband 140 when new structural guidelines are released. So maybe that means updates to AASHTO.
Oh, AASHTO 10 versus AASHTO 9. I don't believe AASHTO 10 is going to have any direct influence on Eastband 140, but we have not looked at it yet. The Eastband 140 that is being released this year, hopefully, is up to AASHTO 9. And so it takes a little while, right? Just like it does for the NSBA Simon or these other design programs that our engineers and owners are using. It takes a little time, but I don't believe there's going to be because again, we're talking about simple span bridges, and updates to AASHTO 10 are for more of the complicated bridges because that's where all the research is. And so the simple span bridges probably will not be affected by that. And so we can have confidence. And you have to remember that Eastband 140 is a preliminary design packet. They're not signed documents. Somebody still has to sign them. And so it is a starting point because what we found was that counties like to put their own little details or their own little idiosyncrasies into their designs. And so Eastband 140 gets them a base design, and then they can modify that according to their own desires and wishes for counties and states. States use it too. And so it is not a signed set of documents. It is a preliminary design where an engineer goes through and finalizes it and signs it.
Great, thank you. Natalie, do you just want to comment again on the PDH, how the process takes place? Looks like there's a few questions on that.
Yes. So after today's webinar closes, I will be sending out an email to everybody who attended, and I will include a link both to the survey that we'll send at the end and then the PDH form for today's webinar.
Okay. Well, again, we want to thank you for joining us. I was impressed with how many people outside of Minnesota joined us. That's really good. We have people all across the country that joined us. And if you're interested in bringing some educational materials on steel bridges to your region or your organization, just contact us. We are willing to come. And we enjoy talking to bridge owners, bridge designers on how they can consider steel bridges.
It looks like we answered all the questions. And just to reiterate, if you want more information on the upcoming workshop that Dr. Barker mentioned, that's taking place on February 19th, that 4-part series, you can register for it now at shortspanstillbridges.org.
So Natalie, thank you to you and Minnesota LTAP for hosting us. Really appreciate it.
Thank you, Dr. Barker and Dan. We appreciate you joining us. We're glad to have brought this out to everybody here today. And like I said, I'll be following up both with the PDH form, the survey link, if you're not able to do that now, and then we will also follow up with links to the recording and the slides once those are available. So just keep your eye on your inbox for messages from me. Thank you so much for joining. Enjoy the rest of your day, and we hope we get to see you at a future training event. Thanks all.
Thank you.
Thank you.